Hi guys, we want to expand on law one and bring a few things that come as a result of law number one. But before that, let's just quickly recap. By now you should know if I have a problem here, suppose I am multiplying 6ab squared c times 2bc squared. Then remember, always signs, numbers, letters. Signs are positive, there's no need to worry. But I gotta group these two numbers. A is alone, there's no A there. And I've got to group a b squared and a b. And then, of course, c and c squared. And you can see now all is nice and easy. 6 times 2 is 12. A b cubed, because there's a 1 there, so you got to add the exponent. The same thing with that. And you are okay with that by now. So now things get a little bit interesting. Let's suppose, as an example, to introduce the expansion of law 1. Maybe we can call this law 1.1 of exponents. If I have x to the exponent 5, and I raise this thing to the exponent 2, if you think about this, I'm going to have what? X to the exponent 5 times x to the exponent 5. And I'm going to add this 2. Remember what I mean by add this 2, I mean the exponents, because bases are the same. And that's going to be x to the exponent of 10. Now, how about this? Check. Suppose now I take the same problem, x to the exponent 5 all squared. What if I did this? X, then I just said 5 times 2. Isn't 5 times 2 10? And isn't that what I had then? So instead of expanding, another result of law number 1 is that, so let me call this law 1.1, of exponent, is that if I have a base raised to the power n, excuse me with the word power, I'm so used to that, raised to the exponent n, then I want to write that m times, then I can simply take this and say n times m, as it happened in the case that I just showed you. So there's another cool law. I want you to think a little bit about this. We're going to try this. You don't have to crack your mind, but how will you write this? Will you expand this 4 times? Well, of course, by definition, we can write x to the 5, x to the 5. You see, I'm even making a mistake, but of course, that's again x to the exponent of 5 times x to the exponent of 5. Remember, this has to be 4 times, okay? 4 times because of that 4 there, okay? That's by law 1. But this is tiring. Imagine that was 10. So the shortcut then says what? I hope you're getting this and saying this in your mind. Instead of expanding this many times, let me just say 5 times 4. And this is x to the exponent of 20. And that's, of course, what we would get here, because you're going to say 5 plus 5 plus 5 plus 5, and you also get x to the 20. So there's the extension of law number 1. I call it 1.1, and not everyone calls it 1.1, of course. But for this series, as you follow through my videos, you will realize that's what I call it. So that's what I wanted to bring to your attention. And by the way, this thing applies. It is still the same thing. It will still apply if suppose I had 3x squared and I raised everything to the exponent 2. Remember, 3 has an exponent 1 there. So I can do this actually, x at 2 times 2. Then I have 3 squared x to the exponent of 4, because 2 times 2 is 4. Okay, it will still be the same thing if I used, suppose here, um, instead of squaring, I decide, well, how about making this a cube? So suppose this was a cube, then I'll have here 3 times what? Times 2. And I'll have again 3 squared, x to the exponent 6, because 3 times 2 is 6. 3 squared is 9. Then I have that. I hope you understand the result of law number 1. Another nice way to have shortcuts. I will come with more examples in the next video, and then I will leave you with some exercises to try before we move into the next section, that is law number 2. And law number 2 talks about division of powers. We just spoke about multiplication of powers, powers with the same basis. That is very important to note. If you still don't understand what a power is, go to video number 1, which brings an introduction to exponents. Thank you very much for watching. Keep supporting and keep well.